All right, so here we are on problem number 6. And note that we have what's called a linear growth model. What does linear growth mean? Linear growth means we add the same amount over and over again. Add the same amount. Sorry, can't write that well today. Over and over again. And that same amount that we keep adding over and over again has different names. We can call it the slope, and we use m to indicate that, or we can call it the constant rate of change. Lots of different names for it, but it's the amount that we add over and over again. Okay, so they're giving us the initial population. That's easy, right? So at time 0, so when n is 0, I've got my population at time 0 is 18. Now, they don't tell me the population at time 1, but I know because it's a linear growth model that I get to the population at time 1 by adding a copy of that slope amount or constant rate of change. Okay, and how do I get to time 2? The population at time 2 will be the population at time 1, which was 18 plus m, and then to get to time 2, I have to add another copy of the constant rate of change, of the slope amount. We keep adding that over and over again. To get to time 3, same deal, right? I take the previous amount, which was 18 plus m, and I add another m. Okay? So we can, of course, shorten this, as we've seen before, by using multiplication. This is really just 18. Let's look at this guy first. This is 18 plus what? 3 copies of m? This is 18 plus 2 copies of m? This is 18 plus 1 copy of m. And if you want, you can even think of this as 18 plus 0 copies of m. Right? Because there's no m's here. So we notice what the pattern is, right? So can we predict what's going to happen by the time we get down to n equals 7? Why am I picking n equals 7? Because they're giving me some data for the population at time 7, so I want to get to that point. So what's the population at time 7 going to be? Well, I already know, right? It's going to be 18 plus a bunch of m's, right? It's going to be 18 plus a bunch of m's. How many? 1, 2, 3, 4, 5, 6, 7. Sorry to squeeze them in there, but not a lot of room. And of course, I can rewrite that as what? 18 plus 7 copies of m. Now, what's good about this is because they gave us the population at time 7, now I have enough info to figure out what the m is. We definitely want to know what the value of the m is, like what is it equal to. Okay, so the way I can figure that out is they're telling me that the population at time 7, in my case, is 70. So I know that this quantity has to be 70. So I can set up a little algebraic equation here. 18 plus 7 copies of that slope, or constant rate of change, has to give me 70. Okay, so if I subtract, we can solve for m, right? We know our algebra pretty well. So we can subtract that 18. I have 7m is equal to what? 52. Divide both sides, so 7m divided by 7 is equal to 52 divided by 7. And so I get m is equal to, and now I have to use my calculator, and I'm getting about 7.4286. I'm going to go out to about 3 or 4 decimal places, and then we'll round at the end. You always want to round at the end, not at the beginning. Okay, so go to a good number of decimal places at this stage, and then round later on. Okay, so now I know what this m is. Okay, so can we write out? So they want us to write out an explicit formula for the population after n weeks. So that means they want an equation. Okay, so population after n weeks is going to be, let's look for the pattern. The 18's never changing, right? So we know we have to start with 18 plus. What's changing is not the fact that we're using the m. What's changing is the number of m's we're using. So the fact that we're using the m is not changing. The number of m's is what's changing, right? This is changing. Okay, in fact, what is the m? The m amount, I could rewrite this. What is my m amount? I could cross out m at this point and put in 7.4286. 7.4286. 4286. 7.4286, etc. Okay, kind of running out of room here, but this, in other words, these m's can be crossed out and replaced with 7.4286, now that I know what they are. So the 7.4286 is not changing. It's the same quantity all the way down. What's changing is how many of them we have. So how many of them do we have? Well, let's check. Let's check how many we have. Okay, at time 3, I had 3 of them. At time 2, I used 2 of them. At time 1, I used 1 of them. At time 0, I didn't use any of them. At time 7, I used 7 of them. What's the pattern? At time whatever the n is, whatever the n value is, that's telling me how many copies of this constant slope amount or constant rate of change amount is being added. How many copies is being added depends on the n. Okay, so how many copies of this 7.4286 am I going to add? Is it 7 copies, 3 copies, 2 copies? It's whatever the n is. Okay, so I'm going to multiply by n. Okay, if I take the 7.4286 times n, that tells me how many copies. This is the number of copies that we add. Number of copies of the 7.4286 that we add. Okay, so I've got my explicit formula. And now I can just plug in 38. Okay, so if I plug in 38, let's see, let me go ahead and do that on my calculator here. Let's see, times 38. And I'm getting, when I work this out, I'm getting 300.29. Okay, so when I do, so at n equals 38, because they want 38 weeks here, I'm getting, at n equals 38, I'm getting P38 would be 18 plus 7.4286 times 38 copies. And that is working out to 300.29. But they want me to round to the nearest whole number, so to the nearest whole number it'd be 300. Once you get to 300.50 and higher, it would go up to 301, etc. Okay, so that would round to 300 in my case. All right, and that's it. So first step is write out the fact that you keep adding m over and over again. Get to the point where you're at the stage where they tell you the value. In my case, it was stage 7. So I had to get to stage 7 and set that stage 7 value equal to what the quantity is that they gave us, whatever the population is. Okay, your data might not go to 7, it might go to a different number, a different time value, but whatever your time value is where they give you the actual population, generate your list of, generate your population expression up to that point, and then set that result equal to the number they gave you, and that will allow you to solve for what this m is, what the slope is. Once you have the slope, you have your equation. Your equation is going to be your initial value, which is the population at time 0, plus the slope amount that we figured out, times n. N is the number of copies of the slope. That's linear growth. Okay, we add the 7.4286 or whatever your number is over and over again, n times. And that's it. That's our equation. And then we can figure out the population at any time we want. All right, cool. Let's go on. Okay, so this is problem number 7. And let's see, we've got 439 streetlights currently, and we're installing 4 at the end of every week. Okay, at the end of every week. So if we're adding, that means we're adding 4 every week. So we're going to add 4 over and over again. So what does that tell you? Because we're adding the same quantity over and over again, that means we have a linear growth model. That's how you tell. If you're adding the same quantity over and over again, you've got a linear growth model. And in fact, in this case, in the previous problem, I had to solve for what that slope or constant growth or constant rate of change amount was. In this case, I don't. They're telling me I'm adding 4. So 4 is my m. Okay? So I can just generate my numbers. The number of lights at time 0. Okay, so when n is 0, my initial population of lights is 439 streetlights. When n is 1, my population of streetlights at time 1 is 439 plus 4. How about at time 2? How do I know that this is the pattern? Because they're telling me I'm adding 4 streetlights every week. So I take the previous amount and add 4 again, etc. Okay, and we can begin to write this out in a more compact way, right? This is really 439 plus what? How many copies of the 4? 2 copies of the 4, right? So the 4 is being multiplied by 2. This is 439 plus the 4 is being multiplied by 1 copy. Okay, this is really, if you want, you can think of this as 439 plus 0 copies of the 1. 4 times 0, my bad. Okay, 0 copies of the 4. Okay, and then could we keep going? What about when n is 3? Could we do that? What's going to happen when n is 3? When n is 3, street lights at time 3 is going to be what? 439 plus, this is my previous amount. This is the amount at time 2. I'm going to add another 4 lights, right? Can I write that using my equation? Sure, that's 439 plus how many copies? 3 copies, right? So what's the pattern? The population, the pattern essentially is this. The pattern is the population at time n is what? Changing or not? Not changing, so that goes into my equation. Okay, is the 4 changing? No, so that goes into my equation. Is what's changing? What's changing, if you think about it, is the number of copies of the 4 that are being added together. Okay, at time 0, I'm using 0 of them. At time 1, I'm using 1 of them. Here it is, right? At time 2, I'm using 2 of them. So I indicate that with a 2. At time 3, I'm using 3 of them, right? What about at time n? What about at time n? I'm going to add n of them, right? So it's 4 times n. Okay, this is, if you remember, linear equations are also y equals mx plus b. I can think this is my y. I can think this is my b plus mx. I'm using, in my case here, in this problem, I'm using n to indicate the number of copies. You can also use x if you like. So these really are the same kind of, these represent the same thing. My m we know is 4, and my b, my initial amount, b represents the initial amount, is 439. Okay, so this really is an mx plus b scenario. Okay, so it's a linear growth model. And we can easily figure out what's going to happen at the end of 31 weeks. Okay, in my case, I'm getting 563 if you want to check it with my numbers. Okay, and then you can go ahead and apply this to your version of the problem. All right, cool. Let's go on to problem 8. Okay, so for problem 8, we've got a linear growth model. Okay, in this case, they're not telling us the growth amount, the constant rate of change, or the slope. They're just giving us a population at time 0 and another population after time 5 weeks. Okay, so can I generate the pattern? We know at time 0, my population is 25. At time 1, my population is going to be what? 25 plus whatever the m is, we don't know. At time 2, my population at time 2 is going to be my previous amount plus another copy. Okay, and we can continue all the way down to n equals 5. Why am I going to 5? Because that's where they gave me some more information. My population at time 5 will be my starting amount plus how many copies? 5 of them, right? Right. In fact, we can write this using multiplication. This is really 25 plus 5 copies of the m. This is 25 plus, this is 2 copies of the m because we were at time 2. This was at time 1, etc. Okay? So, since we know how much we know that our population here is 25 plus 5m, but they're telling us that that equals 380. So I know that this quantity right here is 380. All right, that allows us to solve for m. Okay, how would I solve for m? Well, I know 25 plus my 5m is 380. So what would I do? How would I solve for m? I have to move everything away. So move the 25. So I get 5m is equal to what? 355. Okay, and then I have to divide. So 5m over 5 is equal to 355 over 5, which works out to 71, right? Okay, so it turns out that my m is 71. Now, does that help me solve the problem? Well, essentially what we're saying is, what would be the explicit formula? If I write out the explicit formula, the population at time n is going to be what? Initial amount plus what? We know my m is 71, right? This is really a 71, 71. These are 71s. The 71 is not changing. What's changing is what? What's changing is the number of copies of the 71. That's changing. Okay, once I figure out that it's 71, I can just replace all these guys with 71s. These are all 71s. The number of copies of the 71 is changing. That's what's changing. 1 copy, 2 copies, 5 copies. How many copies am I going to have at time n? Obviously n copies, right? So I'm going to have n copies of the 71. So there's my explicit formula, okay? And we can answer the question, right? All right, so make sure you can do this from scratch. Don't just sort of watch me work it and say, oh, I got it because I watched him work it. Okay, make sure that you can pull up the problem and work it on your own from the beginning. Otherwise, you won't be able to do it on the test. Okay, now is there another way to get the 71? There is. Okay, another way we can do this is as follows, if you want. We can also say that the slope is equal to, you might have seen this equation before, change in the y, y2 minus y1 over x2 minus x1. Okay, in this case, the y's are the outputs. In this case, the population. Okay, so I know the population is 380 at the later time, and the population is 25 at the earlier time. So that's the change in the y's. What about the change in the x's? Now, we use x to indicate inputs. Okay, these are my inputs. Technically, the inputs here would be n's. Right, this would be n equals 0. For time 0, this would be n equals 5 for time 5. Okay, we kind of just, this formula just indicates change in the outputs divided by change in the inputs. So my outputs are the population, my inputs are the time. The time corresponding to the 380 was 5. The time corresponding to the 25 was 0. So if I work this out, I get what? 355 over 5, right? Which is, again, 71. So that's a way to directly solve for the m without setting up all the different steps. Okay, change in the output divided by change in the input between two different data points that we know. This is the data point. Input is 0, output is 25, right? That's my input, my output, or x and y if you like. Okay, this is the data point 5, comma 380. 5 is the input, 380 is the output. Okay, and so the change in the outputs, 380 take away 25, goes in the numerator. The change in the inputs is 5 take away 0, goes in the denominator, and then we get our m value. Okay? All right, cool. So let's go on to problem 9. Okay, so here we are on problem number 9. Okay, and so we have a, we're doing what's called linear depreciation, meaning we lose the same amount over and over again. Lose or subtract the same amount every year or every time period. In this case, annual, right? We're going by years. So we lose or subtract the same amount every time period. If it was linear growth, it would be we're adding the same amount. If it's linear depreciation, we're losing the same amount. But in either case, it's the same amount. So we could just build a little sequence here. I know at time 0, at year 0, I know the value of the truck at time 0 is 30,900. It gave me that, right here. And now at time 1, I know the population at time 1, or value of the truck at time 1, is my 30,900. But in this case, I'm subtracting m. Okay, I'm subtracting some amount. At time 2, same idea. We're subtracting m, and then we're going to subtract m again because we're losing the same amount every year. That's what linear depreciation means. Losing, depreciation means we're losing or subtracting. Linear means the same amount. Okay, so at time 3, we've got 30,900. Take away 2 m's like before. That was the previous amount, and then I lose another m because that's what happens every year. Okay, and they're giving me the value after 3 years. So this value right here, we know what this is, okay? But let's write this in a more compact way using multiplication like we did before, right? This is really 30,900, take away 3 m's. This is 30,900, take away 2 m's. This is 30,900, take away 1 m, okay? So I know that this quantity right here, they're giving me the value for it. They're telling me that this quantity is, in my case, 25,200. Okay. So now can I use this to solve for what m is? Sure. right? So I know that my 30,900 minus my 3 m's is 25,200. So I can subtract, okay? So minus 3,900 from both sides. So I have negative 3m is equal to, let's see, let me grab my calculator here. Okay, I'm getting negative 5,700, 5,700. And now I'm going to divide by negative 3, so negative 3m divide by negative 3 is negative 5,700 divided by negative 3. Okay, what do we get there? Okay, we get that m is what? I get 1,900. Okay? So we're losing $1,900 every year. So therefore, what is my overall explicit formula for the terms? The value of the truck at time n is going to be, we keep the initial, right? The initial's there every year, so that goes into my formula. And then we're subtracting how many copies of the m. Well, first of all, how big is the m? The m is $1,900. That's my m. But how many copies of it? Well, is it one copy that we're subtracting? Or are we subtracting 2 copies? Or are we subtracting 3 copies? How many copies are we subtracting? Well, in year 1, we're subtracting 1 copy. In year 2, we're subtracting 2 copies. In year 3, we're subtracting 3 copies. How many copies are we subtracting in year n? We're subtracting n copies. Okay, so once again, this is like a y equals mx plus b scenario. This is my m times my x. Okay, and my m happens to be negative. Okay, and this is my b. Okay, so it's kind of like b plus mx. My m, you could think of m in this case as negative 1900 if you like. Okay, the idea is it's an mx plus b. It's a number, a constant number, negative 1900. Lose 1900 every year times the number of years plus my starting amount. Okay, that's a linear scenario, and we can easily figure out the value after 6 years. Okay, that's just going to be year 6. Now, is there another way to get the m? And the answer is yes. The other way to get the m, as we said before, was, and this is actually a little bit faster, just think of the data they gave you as data points. So when the truck is new, that means the time is 0 years, and the value of the truck is $30,900. Think of that like an XY pair. Like that's my input, that's my output. Okay, then they're giving me the value after 3 years. So after 3 years, the time is 3 years. That's my input. The output is $25,200. So these are 2 data points. Okay, data point, data point. So I know my slope is equal to change in the y, change in the output, over change in the input. Now, if you want to be fancy, you could call this the value of the truck at year 2. Value of year 2 at the second time point minus the value of the truck at the first time point divided by the time 2, take away time 1. Right, we could kind of think about what's going on in the problem itself, but we usually just remember this as change in the output over change in the input. Okay, the output in this case is obviously going to be the value of the truck. The input's the time. Okay, so the change in the value of the truck is going to be what? 25,200. The second value, 25,200. The second output, take away the first output. So second output, take away first output. Divided by second input, take away first input. Okay, so this gives me what? This gives me 25,200 minus 30,900 over 3. Okay, which ends up being what? 5,700, negative 5,700 over 3, which is negative 1,900. Okay, now why are we getting negative in this case? Reason is when we work using this formula, essentially this is treating m as something you add. So I'm going to add negative 1,900 every year. So my formula would be y is equal to mx plus b. My b is the initial value. My initial value was 30,900. So my initial was 30,900. Okay, my m is going to be negative 1,900 because I'm losing 1,900 a year times x, which is my years. Okay, I could rewrite this, of course, as this way. I could rewrite it as this formula. Okay, I can move the negative 1900 at the end. The reason the 1900 was positive here was because we were assuming it was something we subtract. So if I assume it's something we subtract, then we're subtracting 1900. The word subtraction already indicates the negative. So I'm subtracting 1900. So 19 is what we subtract because I'm putting in the subtractions. If we think of it as something we add because of mx plus b, so we're using addition here, then we're adding a negative amount because it's a depreciation. The truck's going down. Okay? So as long as there's a negative in the formula somewhere, either we placed in the negative, we're losing 1900 every year, or we're adding negative 1900. Same, works the same. Okay? When we use this formula for the m, we're going to get a negative amount because this formula here, change in y over change in x, assumes that the number we're getting is something that we're adding. So we're adding negative 1900 every year. When we work it this way, we're already assuming we're subtracting it. So we're subtracting 1900. So we either subtract 1900 or we add negative 1900. But in either case, what goes here in the formula is a negative 1900. Okay? Once I know it's negative 1900, I can then figure out what happens at the end of 6 years. Very easy, right? Okay, there you go.